We're looking to continue our work with quadratics here. Today we will be graphing. We'll be looking at how to graph them from a table of values. We'll be looking at how to come up with the table of values ourselves. This is suitable for a 3C student if you are reviewing or recognizing your shapes of your quadratics and creating your table of values. Our prerequisite skills that we will be relying on. You'll need to make sure, if you're handling this lesson, again, you'll need to make sure you are comfortable working with your Cartesian coordinate systems. That is your x, y axis on top of each other. That is what you are used to just calling a graph. You'll need to make sure you're comfortable working with your substitution. You'll need to make sure you're comfortable working down, and you'll need to make sure that you are comfortable working with your bedmass. Now, when we are graphing our quadratics, often, as we've practiced already, often we are given our points as a table of values. What I want you to do, because I know you're comfortable working with a Cartesian plane, I want you to take all of these points from the first table of values, throw them onto your Cartesian plane, and then unpause the video, see how you did. We're about to be analyzing the shape that it comes up with together. Good, okay, so hopefully you've seen that right here we did not come up with a quadratic. We did not come up with the parabolic shape with the parabola that we're used to, that we've already practiced looking at. We just came up with a nice straight line. So sometimes when you have a table of values, it gives you a pattern that's a straight line. I'm hoping you can recognize all of these points go in a straight line. They have a common rise and run, as you learned in your previous grade 9 class. We're not focused on that so much right here. I just hope you can recognize they're in a straight line. Number 2, part B, I want you again, take all of these points, throw them onto your Cartesian plane. Go for it. Good, okay, now we're recognizing here, all right, now these new pieces, they do not create a straight line. This is the nice, calm, cool, smooth curve that we have practiced analyzing. It looks something like this. We recognize our parabola, our quadratic, as we discussed before, because it first goes down and then it goes up as we're reading it from left to right. Nice work. Next, I want you to take part C. I want you to take all of these points, throw them onto your Cartesian plane. I promise some of these will be new, but at this point I'm hoping you can see the pattern of what we're doing. We're taking the points, we're coming up with the shape, and we're seeing the patterns. Good, now at this point you're still seeing a bit of a curve, right? Because it goes from a little bit flatter to very steep very quickly. And that's great that you can recognize it. That's our pattern if we're reading it from left to right from our starting point. But there is nothing that goes up on this side, or really that goes down if we're reading it from left to right. There's nothing on this side that follows that same pattern. You'll notice with our purple shape, with our second one that we worked with right here, there was some symmetry, where it looks the same on the left as the right side of this line. That's not the case of this orange one, because it's like there's a missing piece. Well, there is a missing piece, and that missing piece actually is not, we cannot assume that it goes up and it goes really steep. We must assume that it smooths out, because that's the pattern that we were recognizing as we went across. So in this case, we don't have a straight line. And we do not have a parabola. We do not have something that is steep on both sides. If it's not steep on both sides because it's flat on one of them, what you have is called an exponential relationship. All right, an exponential is what's written right here, exponential. Good, now what I want you to do, I want you to try part D. I want you to plot all of these on the Cartesian plane, see if we come up with a linear relationship, see if we come up with a quadratic relationship, and see if we come up with an exponential. Good, okay, now my Cartesian plane is getting a little bit busy, so I will hide some of these pieces to get them out of our way, and hopefully you can see all of these green dots, and you can recognize what kind of a pattern it comes up with. There's no pattern at all. There's a whole bunch of chaos, a whole bunch of craziness. There's nothing that we can work with right here to come up with a shape, so we would call this a non-relationship table of values. We would say there's no relationship between the x values and the y values for green. Lastly, part E, try it out. Same thing, I want you to see if you can find a pattern. Good, for part E, it goes up and then down. Now a quadratic might go down then up, or up then down. Either way, it continues steeply in both directions, left and right. It will go very steep either up or down. It will not go one of them. In this case, it never goes up. Nice work. We have once more a quadratic relationship. So I'm hoping at this point you feel comfortable coming up with your shapes. I was putting these in the wrong spots, but you can fill in those blanks right there. We're going to jump ahead to question 2. Question 2, we're given an equation, and we need to come up with a table of values on our own and then put it on the Cartesian plane. I know you folks at this point can go from a table of values to a Cartesian plane. It's up to you now to come up with your table of values from your equation. So if our equation is y equals x squared plus 2, then it's our goal to find our y values that can fill these in. Our very first x value we're working with is x equals negative 3. So good, okay, we know we're working with right here x equals negative 3. If x is equal to negative 3 and we're trying to find our y value, we can just use our equation from up here. We know y equals x squared plus 2. But in this case, x equals negative 3. So that's like negative 3 squared plus 2. We know from our work with exponents that the base here is negative 3. If the base is negative 3, I multiply negative 3 times itself. I end up with positive 9 plus 2. That is 11. Good work. Okay, if we've come up with our 11 right here, we can plug that into our table of values. We could at this point, if we wanted, throw it on our Cartesian plane, but we're going to leave that until after. And then we can go through once more, try that same strategy, find out all of your y values. I want you to go for it and then compare, see how you do. Good, and on your way through there, you may have recognized, hey, some of our numbers started to get reused. If you saw the pattern, if you got lazy, that's completely fine. Nice work. Now, once you have all of your points, you can throw them on your Cartesian plane. I'm not going to do that right here. I know you're a master of that by this point. You can handle that. Now I want you to handle, you should be able to handle 2b just the same. We're going to handle 2c together. So I want you to try. Pause the video, see what happens when you come up with your table of values with your y values for 2c. Go for it. Good, in this case, when we're evaluating our exponent, we need to make sure we're handling our bedmass first. So we're handling our brackets. That's the inside of our brackets. Negative 7 plus 4. In this case, we're working with negative 3 squared. Well, negative 3 squared, same as last time. We recognize what's happening with our negatives. We're ending up with a positive 9. That is our y value we're working with is positive 9. Our very first point is negative 7, positive 9. We could throw that onto our Cartesian plane right away. And again, I want you now fill in the rest of your y values and then see what you get. Go for it. Good, okay, I'm hoping at this point you can recognize the symmetry. You can recognize that some of these y values are being repeated here, and that's completely fine. We recognize this nice, smooth, calm, relaxing quadratic. Now, at this point, I'm hoping if you followed along and that you're comfortable taking your table of values, putting it onto a Cartesian plane. Nice work.